Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, just attempt to solve it, talk through my thought process, and hopefully it's useful to someone on here. So the problem I'm going to be attempting today is 238 product of array except self. Now as you can see on the right hand side of the screen, I've attempted to solve this before in a previous video, and I spent, I think it was about 15 minutes maybe on it, and I could not get a solution that was O of n at all. I could get an O of n squared solution, but not O of n. So what I've decided to do is look at LeetCode's walkthrough of it, try and understand it myself, write down some notes, and hopefully I can understand like his way of thinking of to come up with my own sort of version of it. So here, return. This is me attempting to solve it, and you can see that you want to find out the test cases. Would require some other data analysis. Did pass. You can see the if I can find it, the product of all is, and then 3 times 0. You could 4 divided by 2, 28. Now, I think, if I'm not mistaken, the test cases did pass, but it was a time limit. Yeah, you can see here, time limit exceeded. So my algorithm wasn't efficient enough for it to pass the sort of test cases they have in place. So, got LeetCode's video up here, and I'm just going to watch it, pause it, and
hey everyone,
just pause it at intervals and try and understand where LeetCode is coming from with the solution.
welcome back, and let's write some more LeetCode today. So today let's solve product of array except itself. So this is another problem from the blind 75 list. As you can see, it's over here, product of array except self. So I'm going to be adding that video solution today. And we're getting one step closer to having every problem in this entire list filled out. So for this problem, we're given an input array of integers nums, and we want to return an output array for every single number that we're given, where for each value in the input array nums, we're basically multiplying every single number except that value and then returning that as the result. For example, in this example, you can see we're given 1, 2, 3, 4. So for example, for this value 1, we would want to return the multiplication, the product of every other value. So for these 3 values, the product would be 2 times 3 times 4. That's going to be 24. So for the first value in the output, we're going to put 24. Similarly, for the second value, we want to multiply every value in nums except for this value. So that's going to be...
So this is kind of what I did. I had an output array. You can see in here I had an output array, or at least that's what I'd kind of written in my notes here. The first time I was trying to solve this, so I'd have an output array with 4 ones, or however many slots n has, or however like n slots. You'd put 1 in each of them, and then you'd multiply the first one by 3, 5, and 4, excluding 2. Multiply 1 by 2, 3, 5, and 4, and you'd go through each slot. But it's just kind of the way that I've went around that's maybe a bit wrong. So I'm gonna continue to watch this.
1 times 3 times 4, that's going to be 12. So the second value in the output array is going to be 12. Now, the hard part about this problem is basically the restrictions that they give us. So we have to solve this problem in big O of n time, and we have to do it without using the division operator. It would be really easy if we could use the division operator, because what we could basically do is...
So this is one of the constraints that I found quite difficult. If you could use the division operation, you could get the product of 1 times 2 times 3 times 4. let's say you wanted to find the product of the array except 4, then you would just divide the product of all numbers by 4. Same for 3, just divide it by 3, 2, or 1.
Is take the product of all of these values, and we know that would basically be 24. So if we wanted the first value, so if we wanted 24, we would take this total product and divide it by 1, right? That would give us 24. If we wanted what the second value would be, we would take the entire product, 24, which would be all of this, and then divide it by 2, which would give us 12, which would be over here, right? Because the division is basically taking the entire product of the entire thing without multiplying by this. Dividing this would do exactly that. But we are not allowed to use the division operator. So
yeah, that's kind of my... When I found out you couldn't use the division operation, that made it a lot more difficult, because that is, like I just said, that's the solution that I would have went with.
Exactly that. But we are not allowed to use the division operator. So if we wanted the product of every value in here except the 3, one way we can break it down is basically get the product of every value before 3 in the input array and get the product of every value after 3 in the array, and then multiply these two values together, and then that's going to give us the value that we would want to put in this position in our result. So it would...
So I just need to rewatch this.
Wanted the product of every value in here except the 3, one way we can break it down is basically get the product of every value before 3 in the input array and get the product of every value after 3 in the array, and then multiply these two values together, and then that's going to give us the value that we would want to put in this position in our result.
Yep. So you're just doing 1 times 2 times 4. But that still is n squared, I guess. So if you were to do 1 times 2 times 4 to get 3, but then you'd also have to do 1 times 2 times 3 to get 4 as well. So
it would be helpful for us if we want to do that for every single value in the input array, if we basically just compute the prefix product for every single position in the input array, right? And then put it in a prefix array. And since we're also going to be wanting the product of values after, it would also be helpful if we computed the postfix product of every single position in the entire input array, right? And we can compute both of these in big O of n time. It's a pretty simple algorithm, right? We'd basically start at the...
Okay. So to get the prefix of, let's say, 1, that would just be, well, there is no prefix for 1 because there's no elements before it. Prefix of 2 would be just 1. Prefix of 3 would be 1 times 2, which is of n. Actually, it wouldn't be of n because you would be just... Oh, okay. This is interesting. It's, if you want to find the prefix for everything, you're not having to, it's not like you're doing 1 times 2, and then 1 times 2 times 3, then 1 times 2 times 3 times 4, you're doing 1, and then you're doing 2 times whatever was the last prefix, then you're doing 3 times whatever was the last prefix, then 4 times whatever was the last prefix. So this is starting to actually make sense now. I think what I'm going to try and do is, just based on this, 3 minutes of watching this video, I think I'm going to try and make some notes based on that. So in here, so we want a prefix and a postfix. Prefix is product of all elements before. Postfix is product of all elements after. Okay, so we've got a prefix and a postfix. Finding the prefix. So to find the prefix, we're going to have an example nums down here. So for index 0, there is no prefix. For index 1, the postfix is just index 0. For index 2, not the postfix, the prefix, sorry. The prefix is the prefix is just the prefix is nums 0 or nums 2, sorry, times we're gonna have prefix is just gonna be an empty array here. With none, 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 none. An array with 4 slots. Or no. Yeah, we're just gonna keep it this. The prefix of nums2 is gonna be equal to nums at index 2 times prefix 1, and then index 3 is going to be nums3 times prefix 2. So that's O of n, just like LeetCode said, that is O of n. Next we have to find the postfix. So gonna start from index. For index 1, 0, 1, 2, 3. For index 3, there is no prefix. For index 2, the prefix is just nums 2. For index 1, the prefix is index 0, 1 times postfix. Oh, sorry, finding the postfix. It's going to be nums 0, 1. It's going to be nums 1 times postfix 2. Then for index 0, the postfix is going to be nums 0 times postfix 1. Okay, and again, that's O of n, so finding the prefix and finding the postfix is O of 2n. That is currently the time complexity that we're looking at. Okay, so I think from here, yeah, I can just go into my notes, or not, go into LeetCode and start typing some of this up. So we're going to take all of this out and replace it with what I have here. There we go. So we need a prefix, and we also need a postfix. So, we're going to do prefix dot append well, you're gonna have to multiply it by something. So I think the it's just gonna be 1 actually. Yeah, I think instead of this being the prefix is 1. The postfix is 1. See how this goes. Okay, so just copy and paste these notes in again. So we're going to do prefix.append 1. And then we're going to do a for loop. So for I in range what we're gonna do the length of nums. Prefix dot append, and we're gonna do nums I times prefix I minus 1, I guess. I minus 1. So I'm gonna go from 1 to the length of nums, and then I'm just gonna put a print statement here just to, you know, confirm that what I've got is right. So we got 1, 2, 6, and 24. So we've got 1, yep, and then we're gonna 1 times 2, and then it should be 1, and then 1 again, and then 6, and then 12. And then we're also going to do prefix dot append nums 1. Let's try that. And then we're going to go from 2 till the length of nums. So we've got 1, 2, 6, 24. That's not right. So we're appending the number at the current index, yep, times whatever the prefix at the index before. So, oh, that's where I messed up. It's 0 here. Didn't read my notes properly. We got 1, 1, 3, 12. Yep. So we've got the prefix. We're going to do for I and range. Well, the first thing we're going to have to do is do prefix dot insert. So this is going to put it at each time we're going to insert it at 0. We're going to put it at the beginning. So index 0, we're going to put, what are we going to do? We're going to be going from index 3 basically. So postfix is just going to be 1 again. Then we're going to be inserting at index 0, we're going to be putting in nums. What are we going to be putting in? Nums. The second last index will be -2. Yeah, -2. And then we're going to do for I in range length of nums. And it's going to be going back one step. I'm just going to make sure that syntax is correct by just printing out I. Um, so we're going to go from length of nums to 0 with a step of -1. Is that how the syntax works? I'm just trying to remember. We go 4, 3, 2, 1. So we're wanting to go to 1 basically. So from the length of this -2. So it's going to be 2, 1. And we don't, or we do the index 0 as well. Okay. So this is 0, 1, 2, 3. And we want to do, we only really want to do 1 and 0 actually. Okay. And it's just going to be doing postfix. It's going to be postfix. We're going to be doing postfix dot insert at index 0. It's going to be postfix at index I plus 1. Yeah. Postfix I times, or no, so sorry, it'll be nums I times postfix I plus 1. Just making this look a bit neater. Okay. Let's print the postfix. Okay. Index out of range. So we go to index 1. Hmm. I think we're probably better doing postfix is equal to none times length of nums. So we can we can address each slot basically. So we're going to do postfix minus 1, so the last index is going to be equal to 1, and then postfix minus 2 is going to be equal to the second last number. No, sorry, it's going to be equal to the last number. I'm just going to print the postfix here. So we get none, none, 4 and 1. So if we look here, that is correct so far. And then here we want to do the current index that you're on, so 1 times postfix of I plus 1. So we want to do postfix I is equal to nums I times postfix I plus 1. Hopefully we don't get an index out of range again. So we get 8841. So let's see. Here it's going to be 4. Here it's going to be 3 times 4, which is 12. Then here it should be... Wait, so here it should be 1. Here it should be 4. Here it should be 3 times 4, which is 12. Here it should be 24. So it's going to be equal to I, which is 1. No, so here it's going to be, the I is going to be 1. So it's going to be equal to nums 1, which is 2. 2 times postfix 2, so 0, 1, 2. So it's going to be equal to... Wait, so that should be equal to num I plus 1? So it should be 3 times... So here the postfix should be 1. Here it should be 4. Here it should be... should be 12. So that would be the postfix to the right. So postfix I plus 1 times nums I plus 1. Let's try that. Yes, that's correct. So now we've got the prefix and postfix. All we need to do now is for is this correct? I don't think this is correct. So this is 1, this is going to be 4, this is going to be 12, this is going to be 24, yeah. Is this correct? So we've got, this should be 1, this should also be 1. This should be 2, actually. So that's wrong. The prefix is wrong. So First one should be 1, second one should be 1 again. So this. What line is the syntax there? And okay, here. There we go. 1126. Yes. Okay. Yep. So now we're just gonna do. So I'm just gonna swap over to my notes here. So next, we're gonna loop through loop through each prefix and postfix, multiplying prefix I with postfix I. That's all we're going to do. And this is going to be, this is O(n) time complexity so overall this is big O of 3n, which is just O(n). So we're going to do the last step. We're going to do for I in range length of nums. We're going to do output. I'm just going to define this up here. Output.append. Then we're going to do prefix I times postfix I. And we're going to return output. We're going to hit run. And it got accepted. We're going to hit submit. And hope. Yes! And my camera started tracking me for some reason. But yes, that got accepted. Which is great. I'm just going to fix my camera. So that got accepted. I'm actually very happy with that. So yeah, I think all it took was just for me to go ahead and watch a LeetCode video for 3 minutes to come up with a solution. So I guess all that's left to do is to tick this off, product of array except self. And now that has been completed. So thank you very much for watching the video. I hope this was useful to you in some way, shape or form. If you had some other solution that was maybe a bit more efficient or just a different way of doing it, please leave a comment below. I love discussing these things. And yeah, thank you once again for watching, and I hope you have a great day.